S12C on Tamiami Trail is here. The easternmost of the S12 structures is S12D right there. And we're almost straight north, about a mile. It's not too bad a canoe ride, but it's up into rigid slough landscape, and it's almost in a direct line to the 3A28 or 3A65 gauge, which is one of the long-term gauges. Goes back to the 50s. And so we do water depths is one of our, or water stage is one of our basic measurements. And they also do it in the headwaters of the S12C, so you can do gradients along that, which is very helpful. Zooming in a little bit more to get a sense of it, there is a tree island. There we go. A tree island over here that if you go on the Osceola Panther tours, they'll take you out to that one. And the bottometer site is right here in a slough between two sawgrass ridges. That's what pretty close to what it looks like now. A few more things have been added to it. Basically, we have lots of electronics in there, internet connection and solar power coming from over on the side. And eventually we'll have a complicated looking, industrial looking arrangement that lets us run a sampling sonde both vertically up and down through the water profile and crossways in the slough to get some variability in representation. And that's what the sample area will look like, or does look like. In here is the portion that's sampled, a ridge across the way. Jim Komanowski's not here at the moment, but the last time we were out, he came along and I did a transect through the sawgrass and got a little crazy, went all the way through and came out the slough on the other side. So we got a nice sense of the elevation difference of the peak in the sawgrass and in the slough. Underwater is what we're mostly interested in. Movement of the water, movement of particulates in the water, and the flock layer, the loose organic stuff down at the bottom, which you can't see too much here, but a lot of it is coming from, we think anyhow, from decomposed bladderwort utricularia, and of course also from nymphaea, from water lilies. So that's underwater, and that is flock artificially stirred up at that point, but giving you some idea up close. It's hard to get pictures, but you get some idea. This is stage water depth at the site, and blue is at that gauge that I mentioned, the long-term one. If you look close, you say, well, gosh, he didn't do a very good job of lining up his graphs. It lines up pretty well in here and in there during the drying. In there, the difference between the blue and the red, that's the gradient. That's the elevation difference that's driving flow, not elevation difference, but water head difference. And then we recently put out in the slough a specific conductivity, electrical conductivity sensor that runs long term. All of these measurements are intended to be multi-year. And I thought, conductivity, that's going to be a pretty boring measurement. There's just not going to be much going on. And it actually turns out to be much more interesting than you would think. Oops, that is if you don't push the wrong button. This is conductance here. It's rising slightly. This is about a week-long period, and it continues to rise there. What's the kink? Taking guesses. There's more or less a step function jump there.
A management change?
Not a management change.
Rainfall?
Rain event.
And there's the rain event. Correlates with stage. And if you look real close, our timing is 15-minute interval. And we could go finer if we wanted, but that usually works pretty well. If you look real close at some of the events, there aren't any other ones on this one, you could actually see, because we have rainfall, stage, and now the conductivity, you can see the timing of some things, and you may get an increase in flow and in stage before the rain hits that location. As far as we can tell, that's upstream water coming down, and you're being able to pick it up. Other times it's very synchronous, that you get rainfall at the station and the water level goes up as you expect. But so that signal is dilution with lower conductivity rainfall, and the longer record has more interesting stuff in it, but this is all society. So that was the teaser. If anybody is interested in doing either point measurements out at the fluxometer, having the benefit that you've got multiple years of context for it, talk to me. Or if you want to actually set up some long-term things there, we're happy to consider that. I work on that with the colleague Jim Brock out in Boise, Idaho, actually, but he comes back and forth. We've both been working on this for a number of years. So now let's go more broadly into the ridges of the landscape. Descriptions that, if you looked in the book, they're in there somewhere. This, for me, is the key word, alternating. And those of you who've been out north of Alligator Alley, maybe less so south, north of Tamiami Trail, less so south of it in the park, but north of it, that alternating, this description reads true, that you've got sawgrass ridges alternating with open leads. And if you go back in the older sources, when somebody was thinking about putting a railroad across the Everglades and he made this expedition go out there, as long as they were going more or less north-south, lined up with the sloughs, the troops were reasonably happy. When somebody said, you got to go crossways, you start seeing a lot more complaints in the accounts, because now they have to push through those ridges. The sloughs were easy to travel, the ridges were not. And that difference in ease of travel is two parts. Part vegetation and part something else, which we'll come back to. The plenty of water is also, in my mind, quite important. Obviously, if it was just one observation on one day, that doesn't carry a lot of weight. But when you look at all the observations, the observation of plenty of water in the sloughs seems to hold up very strongly and gives us some idea of what should reasonable depths be now. And the answer to the core is plenty of water. We can do better on quantitative. If you look at the surveyors, they reinforce that alternating idea. This is the account from 1 mile of a surveyor. In this case, he's going crossways across the landscape axis, so across ridges and sloughs. And you can see he's alternating back and forth between lily pad, nymphaea sloughs, and sawgrass. At this time, there probably already was some invasion of wax myrtle, but he's going back and forth over that. And the edges were distinct enough that the guy is actually measuring it to 2 decimal places. So it's not a fuzzy edge that you don't know where to put it. It was something that they could easily do. And there are pages and pages of these accounts. Not over the whole Everglades, but coming in from the eastern edge. There's 1917, I think this is. This is actually quite close to where we are, a little bit east of us. No, west of us, sorry. Turn around. A little bit west of us, although not very far west. And same sort of thing. Sawgrass ridges, some tree islands, and sloughs, and with a sharp edge on the sawgrass. Looking at it now, the directionality is not all that obvious if you're right down on the ground. But if you go up a bit, it starts getting a lot more obvious. So if you ever get a chance for helicopter rides, don't ever pass it up. It's worth getting seasick or whatever you get in it. It's you get a real sense of how the landscape is organized. Tree Island and all of these are sawgrass ridges. The whitish is open water slough, or as you can see, the open water is actually full of water lilies at this point. All those little green dots are water lilies in that one. And similar, this is what it looks like in what we call Central Conservation Area 3A, north of Tamiami Trail, south of Alligator Alley, west of the L67 levees. The middle section of it looks pretty good, and that's our best sense of what it used to look like. And that's based obviously not on the aerial photographs that I have out of my grandfather's attic from 1850 that don't exist, but because our earliest aerials are 1940, which isn't very far back given the drainage history of this system. But from 1940 forward, in this area, most of the patterns are very stable, despite changes in management. And then extending it backwards to the narrative descriptions, it seems to fit pretty well. So we've looked at it mostly in plan view from above, but what is making that pattern? And that is to me the most fascinating part about this system. Other folks who are more, I'm soils and plant oriented, other folks who are animal oriented are going to say, well, this is all very interesting, but aren't there any animals out there, and don't they do something, and don't they like something or dislike something? And that is all true. Habitat created by this mosaic is very important to how the system functions, but it's not my area, so I won't tell you about it, but there are other people here who can. But what to me is fascinating is when you put on your X-ray glasses and realize that underneath everything that you see in that picture is not rock, but peat soil. A layer of peat that's thick enough to disconnect you from the underlying bedrock. So whatever is going on in the bedrock has nothing to do with what you see up here. It's all pattern that's etched in one or another way into the peat that's above it. And that's pretty interesting, because that clearly is a very organized, you can call it self-organized if you like, picture. And so one of the questions is, all right, we know pretty much what it looks like in plan view. How does that correspond to cross-section? What is making this pattern of the vegetation? And I am very convinced, and have been for a long time, and I think most people are, that what you're looking at is simply a difference in hydrology, which in turn is a difference in peak elevation. And it's critical. So here's your Sawgrass Ridge in cross-section now, running east to west, more or less. And relative to the bottom of the slough, in the original system now, as best as we can make out, about 1.5 feet of difference between slough and the surface of the ridge. So when I mentioned out at the flockometer that when I was out last time, I sounded water depths going across from slough through the ridge and out to the other slough. So you can, by doing the water depth and assuming the water is flat over that thing, you can map this ground surface elevation. And we've done this many, many times. Other people have done it. I tend to believe in doing it in a deterministic sort of way. So I walk across these things. Other people are more statistically oriented and they'll take random samples in this landscape. Either way, you tend to come up with the same picture, that the ridges are higher than the sloughs, and that seems to be the hydrologic basis for supporting those different species. You will not find anywhere that's 1.5 feet elevation difference out there now. If you got 1 foot, you'd be doing well. If you got about 8 inches of elevation difference, you'd be, that's typical. And that difference goes to 0. And we'll talk a little bit more about that. If you go into the early descriptions, and of all the things that I showed you before, the early descriptions and map them out spatially, you can get kind of an idea of where this landscape originally was. It extended up to what's now Loxahatchee Refuge, Water Conservation Area 1. It actually had a little arm that is now sugarcane fields, but you can sort of see it in Google Earth, the traces of it, that almost made it to Lake Okeechobee. There was a high burn there. A piece of it went up to what's now Grassy Waters, the water supply for West Palm Beach. And it went all the way over to the Big Cypress, and it went quite a ways east, as all of you down here know. It was east of the Miami airport originally, and we chopped out a chunk of it. But the descriptions are similar enough that at first cut, pretty similar over that whole length of it. And that's quite a big chunk of the original Everglades. It also happens to be most of what's left. We don't have much of the Sawgrass Plains left, and we don't have as much of some of the other ones. Lest one thinks that governors don't know anything about the natural environment, this drawing is courtesy of one of our governors right around, I think it was 1905, 1907. Now, of course, he was drawing it to help illustrate why we ought to drain the Everglades, but nevertheless...
No, it must be Broward, right?
I don't think it was Broward. I'm drawing a blank on who it was, but it wasn't Broward. Broward's surveys, though, he did actually survey. His surveys are terrible. He could care less about natural stuff. There's no mention of plants. The earlier surveys are much better. His are no good. What you're looking at here, as far as I can make out, I'm speaking for the governor, he's doing a cross-section from Lake Okeechobee to Biscayne Bay. Correctly, he's got a slope to it. He's got the coastal ridge in there. And he's got these funny little divots that you go, well, what the heck is, why do you bother to draw that in? What are those? Well, those are, remember that his cross-section is running basically parallel to the orientation of the sloughs. and of the ridges. So that's a ridge, that's a slough, that's some more ridge, that's a slough. And in that direction, the sloughs are short. If he'd run it the other way, it would look different. Why he put Lombardy poplars on the tree islands, we don't know, but hey, he's a governor. But the key piece, the two key pieces in my mind of this system, or let's say three. Patterned, it has an organized structure to it. The organized structure has nothing to do with the bedrock as far as we can make out. It's all a feature of the peak. Two, it has that peak base to it.